Hello class. So we're going to do the homework for 7.4. This is the class with the Excel. So let's go ahead and jump on it and we're going to do questions 6 and 7. So let me go ahead and pull up my Excel. Alright, so it asks for, is it appropriate to use a normal approximation to find the probability that more than 45% of the people in a sample have high blood pressure? Alright, so the formula to see if it's appropriate to use the normal approximation will be, so let's go to our ebook, and this, so essentially limit theorem for proportions will be, long as it passes test, n times p is greater than 10, and n times 1 minus p is greater than 10. So let's go ahead and try these. Okay, so first one, n times p. So we got 0.4 times, so 0.4 times 37% equals, a high blood pressure has been identified as a risk factor for heart attacks, strokes. The proportions of U.S. adults with high blood pressure is 0.4, sample 37. Okay, perfect. 0.4 times 37 for 14.8. So that is above 10. And the next one, so 1 minus 0.4, which is 0.6. We just do that in our head. So 0.6 times 37. And again, I got zero point 0.6 from doing 1 minus 0.4, because that's what it asks for. N times 1 minus P. So 22.2. And that is greater than 10. So it passed the test. So it is appropriate. Question 2. The probability that more than 45% of the people in the sample have high blood pressure. Alright, so go ahead and delete these. So we're going to have to find the z-score in the area. Alright, and so the formula for the z-score will be this right here. For proportions is p times 1 minus p divided by n over the square root. So that's what we're going to do here. Come on. Come on. Alright, perfect. So equals 0.45 minus, the mean is 0.4. 0.4. Ooh, excuse me. Before we do any of this, we have to find standard deviation. Sorry about that. So let's do that. SD. So the formula is, so we got the square root and the square root of p, which is 0.4, times 1 minus p, which is going to be 0.6, divided by n, which is 37, and all this is square rooted. So that's our z-score. That's our standard deviation, excuse me. Now for the z-score. And here's a formula for the z-score that we will be computing. It right here. So p minus the population, the mean over the standard deviation of the proportions. Alright, so our z-score is 0.45 minus 0.4 divided by our standard deviation. So let's put this to 2 decimals. Because z-scores for our tables use 2 decimals. So I'm going to put it to 2 decimals. So 0.62. So z-score 0.62. So let's find the area for 0.62. This is positive. So 0.62. 0.7324. 0.7324. But remember, they're asking for what's greater. They said more than. So when they ask for more or greater, we have to use the complement. So we have to minus our probability. So equal 1 minus, and bam. So that will be our answer. 0.2676. All right, check. Perfect. A new sample of 83 adults is drawn. So this one, we have to change the standard deviation. So everything is the same except the sample size. And they're saying 83. All right, perfect. Find the probability that more than 41% of the people have the same 41% of the people in a sample will have high blood pressure. And high blood pressure is when you have 0.4. Or the proportion is 0.4. So let's go back down. So our x value is 0.41. So we're going to delete that. So our z-score formula, so 0.41 minus our mean, 0.4, divided by our standard deviation, which is our new one we just computed, so 0.19. So the area for 0.19, and they're saying more than, so we know we're going to have to do 1 minus, so 0.19, 0.19. All right, so 1 minus 0.5753. All right, and that will be our answer. 0.4247. All right, find a proportion of individuals. All right, sample that are between 26 and 32. Let's go do this one down here. So we're going to have to find the z-score for the first point, the area, and the z-score for the second point, and the area. I just like to call it area 1, area 2, just so you know which one is which. And you can start with any of. You can start computing a z-score for either 0.32 or 0.26, but I'm gonna just start with the 0.32. I just like to start with the higher data value. So equals 0.32 minus our mean, which is 0.4, divided by our standard deviation. All right, 1.49. So let's find the area for that. So negative 1.49 will be right here. Boom, boom. 0.0681. All right, for now the second value, which is equals 0.26 minus 0.4 divided by our standard deviation. So negative 2.60. So negative 2.60. All right. So our area is 0.0047. So when they went between two values, we always just subtract the higher value from the lower value. So equals, this is the higher value minus the lower value. All right, so then that would be our area for the portion that's between the two values, 0.0634. Perfect. Find proportion that's less than 27%. All right, so let's find the z-score. So for 27, so let's go ahead and plug that in. So 0.27 minus 0.4 divided by standard deviation. All right. Round out to 2 decimals. All right, so let's put their area. So negative 2.42. So 2.42. It's negative 2.42. So that would be our area. 0.0078. 0.0078. Perfect. Yep, just for 7.4, long as we use our formula to get our standard deviation, then our z-score formula. So that's the only things we're doing. Will be unusual if more than 31%. All right, so the z-score, we'll do it for the point that's 31. Our formula, so we got 0.31 minus 0.4 divided by standard deviation. All right. Just go ahead and bring that to 2 decimals. You don't have to do this part. I just kind of like to. All right, so let's go ahead and find our area. And we just know that since they're asking for more than, we're going to have to do the 1 minus. So I'm going to just put it already. 1 minus, so negative 1.67. 1.67. All right. So 1 minus 0.0475. All right, perfect. So 0.9525. So that would not be unusual because so unusual, you only put usual if it's less than 0.05. And of course, this is extremely higher than 0.925. All right, perfect. And that's how you do problem number 6. All right, thank you guys, and see y'all soon.